Okay, so right now I'm going to derive the law of sines, and there'll be an example problem afterwards. And the only thing it's not going to address is the ambiguous case. And so our law of sines, I have this, to start out, I have this triangle ABC, and it's in your traditional labeled arrangement where the opposite sides have the same letters. The angles are labeled with capital letters because they're actually labeling points that are vertices of the triangle, and the opposite sides are measures or variables for measures, and so they're lowercase letters. I drop this altitude from angle vertex A or angle A to side BC, forming point D. And so this altitude, I've labeled its length with H, and since it's an altitude, it's 90 degrees to that side. So I formed two smaller right triangles within triangle ABC. So I'm going to use this diagram to derive the law of sines. So law of sines. Let's start out with taking the sine of angle C, and the sine of angle C is going to be length of the opposite leg, H, divided by the hypotenuse B, and I'm using the left triangle because that's where side or angle C is at. I'm going to multiply both sides by B, and so I get B sine C is equal to H, and I'm going to stop there and hold off and use that in a second. In the meantime, I'm going to take the sine of angle B. So I didn't change the color that I intended to do. So the sine of angle B, and the sine of angle B is the length of the opposite leg, H, over the hypotenuse C of the right triangle. And so I get that, and I'm going to multiply both sides by C, so I get C sine of angle B is equal to H. Okay? And so now I can do the following. We know that H must equal H. Why? Because of the same side, right? That's the same side, so it has to be equal to itself. But I have this representation of H and I have this representation of H, so I can do the following. B sine C substitution, and then I can do this substitution, C sine B, and then if I divide both sides by C and at the same time divide both sides by B, then these two B's equal 1, and I get sine C over C, and these two C's equal 1, and I get sine B over little b. And so that's 2/3, or if you want to say one equation for the law of sines. If we wanted to continue and formally complete this, we would need to drop another altitude, for instance this altitude, and do the same thing. Note I could take the sine of C and it would equal, let's say this is Q, so the sine of A is equal to Q over B, right? And then I can take the sine of B and that's equal to Q over A, and then I could do the same whole thing and I'll have sine A over A is equal to sine B over B. And I guess since I pretty much just did it, I'll just write it down. Sine A over A is equal to sine B over B. Okay? But if sine C over C is equal to sine B over B, and sine B over B is equal to sine A over A, then via the transitive property, we know that sine C over C is equal to sine A over A. And so with these three relationships, those three equations, we have the law of sines. Now, you would always use them in this format as something equals something, or specifically a fraction equals fraction, or if you prefer, that is a proportion. And this law of sines are just proportions. It's taking advantage of the proportionality of triangles. But we often write the law of sines in this manner. Sine A over little a, the length A, opposite side, sine B over B is equal to sine C over C. Not often will you use this in that manner. I have. I tried once, one year, and it just messed up all the students, so we backed out of it. Because you can do some of that work, but you have to know what you're doing. All right? So, what do we want to do? We want to do an example now. Okay? So, an example. So let's give you an example. Let's go with angle A is equal to, I don't know, 53 degrees. And let's go with side, I don't want to go side A. I want to go angle B is equal to 23 degrees. And let's say that side B is equal to, not side B. Yeah, sure, side B. Side B is equal to 7 centimeters. Okay? So, what I look for is, we're not going to actually do this example. I'm going to show you. Let's write that example down. I'm going to write another example down and come back and look at this, because I just want to get. I can kind of get two examples taken care of it in one shot. So let's say this is 61 degrees. Let's say that I give you side B is 5 centimeters, and angle C is equal to 53 degrees. I just picked 53 degrees. I don't know why. Okay, so this is the example we're going to work on. I'm going to come back and point that something out so we don't have to do this green one out. We can just do this orange one. So notice, if I write the law of sines out, sine A over A, sine B over little b, sine C over little c. Change colors. You're given A, so you have this number, right? You're given C, you have this number, right? And you're given this length 5, you have this number. So as of right now, maybe you guys remember and you're jumping ahead of me, I cannot use this equation because I have two missing variables, little a and big B. I cannot use this equation because I have missing C and missing B, right? And I can't use the equation that's this portion with that portion because I'm missing little a and little c. So I have three equations, but I have missing unknowns, two missing unknowns in each equation, so that's not doable unless you start thinking about system of equations, which is essentially what we do, but we insert an easier equation in time. So what I'm pointing out, or trying to point out, and possibly doing a poor job, is you can identify a law of sines problem very easily by determining that if I have one of these fractions, or half of the proportion, then I will have one of these other guys, one of these other four pieces of information, and I can complete one of my equations. And then from there, I can then find the third angle and complete the third equation. So if I have one of these pairs, I'm all set. And that's kind of what I want to show you. In this first example, I have one of these pairs. I have b over b. I have sine b over b. So that I can set up one of these fractions and I can figure out what side A is. And in addition to that, I can use triangle sum to find the third angle and then find C. So let's finish this orange problem, and that'll be enough for this guy. So I have these two angles, and so angle A plus angle B plus angle C is equal 180 degrees, and that's triangle sum. So 61 degrees plus B plus 53 degrees. And no, you don't have to write all this down if you don't wish, but remember, if you make a mistake and I don't have the work, I can't give you partial credit. So look, takes 2 seconds, write it down. So B is going to be equal to 180 minus those numbers, right? Buck 80 minus 61 minus 53. Did I type it? Yes, 66 degrees. Okay? So now I have sine of A, and A is 61, over little a, which I don't have, equals sine of B, which is 66, over little b. Is that the one I have? Yeah, 5. So let's just drop that in there. 5 centimeters is equal to sine of C, which is 53 degrees, over little c. Now I can use this guy to figure out what little c is. I can use this guy to figure out what a little a is. So something with proportions, if you don't understand that you can do this, or you're like, well, how? What? He can do that? But you can do that? Ask me in class. A over the sine of 61. Ask me why it works. 5 over sine of 66. Multiply both sides by sine of 61, so I get A equals 5 sine of 61 over sine of 66. And so I get A equals 5 sine 61, enter, divided by sine 66, pow. 4.78695, which is approximately 4.7 0.79 centimeters. And I'm almost always going to try to use that pair because this number is less accurate since I just rounded it. And so if I use this pair with that, I'm going to introduce a small bit of error. These two integers, 66 and 5, don't have any error involved. So the second part, I'm going to have little c over the sine of 53 is equal to 5 over the sine of 66. And so c is equal to 5 sine 53 over sine of 66. And I know my writing's sloppy, but I think you can sort out what's going on, or you can hit pause and figure it out. So 5 times the sine of 53 divided by the sine of 66. Hopefully I plucked out the right numbers, and I get 4.371077013, which is approximately equal to 4.37 centimeters. Now let's line these up. I have little a, little b, little c. Little a is 4.79, little b is 5, little c is 4.37. Big A is 61 degrees. They're all really close to each other, so this is a pretty nice little test here. B is 66 degrees, and big C is, 53 degrees. What's the least angle measure? C. What's the shortest side? C. What's the greatest angle measure? 66. What's the longest side? B. It works. All right? So that's the law of sines. There'll be a separate video on the ambiguous case because it's more involved, and I might even do it in class. Well, I'll definitely do it in class. I won't do the derivations in class. We'll just do some problems. All right?